Okay, this one's on section 4.4 on complex numbers, and you could actually almost call it complex numbers, and it's kind of a review of square roots also. First, the author takes you through how do you solve an equation like x squared equals -1. Okay. You know that it's an x to the second, so there ought to be 2 answers. Okay. We said if there was an x to the third, there would be 3 answers, and so on. On this one, if you take the square root of both sides, okay, square root of x squared is just x. Okay, and this introduces a whole new level of number systems. Square root of -1 is defined as I in math. Square root of -1 is defined as I. And we're taking a square root, so it's positive or negative I. So the 2 answers are I and -I. Okay? This goes way back in math, all the way back to the 1500s. And if you look at, there's a pattern. The square root of -1 is defined to be I squared. So if you square both sides of that, I squared is -1. If you look at I to the third, I to the third is the same as I squared times I to the first. Because when you multiply monomials, what do you do with the exponents? Add them. And then I squared is -1, so that's -I. I to the fourth can be split up into I squared times I squared. But I squared is -1, so you'd have a -1 times a -1, which is a +1. And the pattern repeats every 4. So it's going to go I, -1, -I, and then 1. And then it would start all over again. I to the 5th would be I to the 7th, -1. Yeah. Did I say that right? I to the 5th would be I. And then I to the 6th would be negative, and it repeats every 4. And the one I use a bunch is the I to the 4th. I to the 4th is 1. So like on an ACT type test, if they said simplify I to the 100th power, you're looking for powers of 4 or powers of 2. I do it by powers of 4. I would say this would be I to the 4th and raise it to the 25th power. Because when you raise a power to a power, what do you do with the exponents? Multiply them. And I to the 4th is 1. So 1 to the 25th power, 1 times 1 times 1 times 1 is just 1. So if you look for powers of 4, like if I did, let's say I did I to the 27th, okay? I can split that up into I to the, let's say 24th times I to the 3rd, right? Because if I multiply, I add the exponents. And this would be the same as I to the 4th and raise it to the 6th times I to the 3rd. But I to the 4th is 1 to the 6th, and I to the 3rd is -I. So 1 times a -I is a -I. So you can either look at powers of 4 or powers of 2, okay? But the main ones that you'll be using is I is the square root of -1, and I squared is -1. Those two, okay? The next thing the author goes through, and I'm going to go through several examples on this, but first the author goes through for non-negative real numbers, and I have to emphasize these are non-negative. Okay, for non-negative real numbers. A and B, real numbers A and B. The square root of AB, you can split it up. If it's a square root, you can split it up into the square root of A times the square root of B. It goes both ways, as long as those are non-negative. Okay? Yep. Okay? And the square root of A divided by B, you can split that up into the square root of A times the square root of B. So if those were two negative numbers, or either one of them was negative, you can't just multiply them together like that. Okay? Okay, then we also have to go back and talk about when they say to simplify, and if you have radical answers, and I know you did it a bunch in Algebra 1, if they say simplify your radicals, what that means is two things: no radicals in the denominator, so you have to rationalize the denominator, and number two, no perfect squares. No perfect squares inside the radical. Another way to say that is no perfect squares. No perfect. Let's say no perfect factors. No perfect square factors other than 1. So it's very similar to National Reduced Fractions Day. You have to simplify all the radicals. Okay. Before we go through the problems, I want to talk about the perfect squares. When they say you've got to simplify, you look for largest perfect squares. 1 squared is 1. 1's a perfect square. 2 squared is 4. 4 is a perfect square. 3 squared would be 9. 4 squared would be 16. 5 squared would be 25. All of these are perfect squares. Okay, 6 squared. So you're going to look for the perfect squares, and then you can factor it back. 7 squared would be 49. 8 squared would be 64. 9 squared would be 81. 10 squared would be 100. 11 squared, 121. 12 squared, and that's probably about where we start. 13 squared is 169, and that's when 14 squared, I'd have to look, 196. 15 squared is 225. 16 squared is 256, and the rest of it you'll probably do on a calculator. Okay, so those are perfect squares. So when you go to simplify your radical, you're looking for those numbers inside to try to simplify. Okay. Okay, so now let's go through. I'm going to take you through several examples, and all the directions we'll say is simplify. Okay, on number 1, square root of 18. So you look for the largest perfect square inside 18, and that would be 2 times 9, and out of that square root of 9 you can take out a 3. 3 radical 2. Am I right? You've done these? Okay. Square root of 147. And you may have to try, a little bit of trial and error. Okay, but on this one, it's 3 and 49. Square root of 49 is a 7. 7 radical 3. Okay. On square root of 72, you can go 9 and 8, but that's not enough. You can go 9 and 4 and 2. So the largest perfect square inside there, 36 and 2. So you can take out a 6 radical 2. Okay. Number 4. Now they're going to start putting in the square roots of negatives. Okay, and for a while I would write it out the long way because it saves some errors. So what I do on this is I first split it up into -1 and then times 28. And 28, the perfect square inside there's 4 and 7. So now square root of -1 is I, the imaginary number. Square root of 4, you can take out a 2, and what they're going to do is they're going to usually write it 2i, and then the square root is 7. Okay. So they gave you the square root of -9. I split it up into square root of -1 times 9. Okay. Out of this I can take out an I. Out of this I can take out a 3. 3i. Yep. Let's see. Now they're going to throw in the variables. So let's say I gave you the square root of -32y cubed. I didn't write that very good. Let me write that again. Okay, so simplify it inside the radical. That'd be -1, largest perfect square inside 32, 16 times 2. And I go ahead for a while and split this up into perfect squares inside with the variable. So that's y to the second times y to the first. Because if you multiply them together, multiply the monomials, you add the exponents. So then, out of this I can take out an I. Out of this I can take out a 4. So I'd have 4i. And then out of this, the square root of y squared is y. And what's not circled is still inside. Radical 2y. Okay? And I emphasize on my eyes. I try to put a tail, and I usually try to put a bigger dot on the eye. Okay? Let's say I gave you the square root. Up in the numerator is 10, down in the denominator is 81. By the rule we had back up here, says you can split that up, okay, into the square root of a and over the square root of b. So I'm going to split it up, the square root of 10 over the square root of 81. Square root of 10, there's no perfect squares inside there. Square root of 81, 9. And you're done. Okay. Okay. Another example. Say I have the square root, and extend that radical, so you have square root of 33 over 50. Okay. So we can split that up into the square root of 33 over the square root of 50. 33, 3 times 11, that's as far as you can go. So, and largest perfect square inside 50, 25 times 2. Out of that, I can take out a 5. So I'd have 5 radical 2. Now, the problem is, you're not done, because part of that rule up above said no radicals in the denominator. So you've got to rationalize the denominator. To rationalize that, you've got to multiply by radical 2 in the denominator, so multiply the numerator by radical 2. Okay? So then you'd have radical 66. You still have to check that. 6 and 11, there's still no perfect squares inside there. Radical 2 times radical 2?
Radical 4.
Radical 4, which is 2. 2 times 5 would be 10. And that's your final answer. Okay? Questions on that one? Am I right? You rationalized denominators? Okay. Another one. Say I give you the square root of a negative 125x to the 5th. Okay, split it up. -1. Largest perfect square. 25 and 5. And I go ahead and split it. Now you can go 2 ways. You can go x squared times x squared times x, or you could go x to the 4th times x. For a while, I'm just going to go x squared times x squared times x. Okay, so out of this I can take out an I. Out of this I can take out a 5. I can take out an x, and an x would be an x squared. Okay, so I'd have 5i x squared. And what's not circled stays inside 5x. Okay, that's as far as you can go on that one. Okay, now this next one, they're going to work with the I values, and say they have a negative 3i times 2i. Very similar to what you did with just x variables. Multiply the numbers in front. So negative 6 and I times I squared, but I squared is negative 1. So you have negative 6 times a negative 1, which is a positive 6. Okay? That's your answer. Okay, another one. Say you have square root of negative 12 times the square root of negative 2. Very tempting to say that's the square root of 24. Anybody have that thought? Ignore that thought because you can only multiply those together if those are non-negative numbers. Okay? Star that, highlight that. You can't do that unless they are non-negative. So, you cannot say that's the square root of 24. What you have to do is split this up and say that's negative 1, largest perfect square inside 12, 4, and 3. Okay, negative 2, split that up into negative 1 times 2. Out of this you can take out I, and out of this, so we'd have 2I, radical 3 left, times, out of this you can take out I, radical 2 left. Now multiply the numbers in front. 2I times I, 2I squared, radical 6, but I squared is negative 1. Yep, final answer, negative 2 radical 6. Okay, so you've got to catch yourself. This, you cannot just multiply the numbers inside if those are negative. To be able to multiply the numbers inside, they have to be non-negative. So this is one when you're getting ready to study for the test. I'd start that one. You definitely want to catch yourself on that one. Okay, so we're going to take this now into equations, and they will just say on these to solve. Okay, so x squared, this is number 12. X squared plus 49 equals 0. Sorry, 49. You can subtract 49 on both sides. You cannot factor the sum of two squares. That's not possible. Okay, but you can subtract 49 and you get x squared equals negative 49. Take the square root of both sides, and every time you have a x variable and a square root, you're always getting two answers. You consider positive or negative. Okay, positive or negative, and then out of this, split that up. You can take out an I, and you can take out a 7. So final answer, positive or negative, 7i. There's two answers there. X is 7i, X is negative 7i. Okay? Questions on that one? The imaginaries are we're only gonna worry about it with the even powers. Yeah, squares. Yeah, because cubes, you can take the cube root of a negative 8. Like negative 8, negative 2 times negative 2 times negative 2. Yeah. Yes?
You have math, and this is solved.
Do what?
How do you tell the difference between that?
On this one, you can't, no matter how hard you try, you can't factor the sum of two squares. You can factor the difference of two squares, but some, like you could say, try this, and you'd have a plus 14x, that doesn't work. And you could try this, and you'd have a minus 14x middle term, that doesn't work. Yeah, sum doesn't work. Yeah. Difference of two squares you can factor, but sum you can't. And that's why I purposely put that on there. Okay, let's try another one. Say you had to solve. This one still solve. 5x squared plus 20 equals 0. And remember, it's in standard form equal to 0. If they don't give it to you equal to 0, you need to get it in the form equal to 0. Okay, so on this one, first I would subtract. And you'd have subtract 20 on both sides. You'd have 5y squared equals a negative 20. Divide by 5. So you'd have y squared equals a negative 4. Take the square root of both sides. Yep, so you'd have y equals, and I'm going to go ahead, it's positive or negative. You have to remember to put the positive or negative. The author's not going to tell you that, and I'll count it wrong if you don't have both answers. So you have, out of this you can take out an I, out of this you can take out a 2. So you should always have, when you take the square root of both sides, you should always have both answers, positive or negative, 2i. Okay? Okay, then on the next thing the author defines is a complex number. Today, you need to remember this date, November 7th, okay? You are taking your level of math from the real number system up one step higher to the complex number system. That's the highest it goes, okay? A complex number is any number that can be written in the form a plus bi, where a and b are both real and I is the imaginary unit. Okay, and if you write it like that, a plus bi, the a by itself is the real part. The bi is the imaginary part. So if I gave you an answer like 5 plus 3i, 5 would be the real part, 3i is the imaginary part. If I gave you a number like 8, that's the same as 8 plus 0i. 8 would be the real number, 0i would be the imaginary number. Okay? You can do all kinds of operations with the complex numbers. Okay, so they will give you problems like this to simplify. So they give you the quantity 3 plus 5i, that quantity plus the quantity 2 minus 4i. You have to think of the I terms as, because you're adding or subtracting like terms. So I would combine the real parts, and it's an addition sign in between. So 3 plus 2 would be 5. And then plus 5i, yeah, plus 1i, or just I, right? It's okay if you put the 1 in front, okay? So you're just combining like terms. If they give you 4 plus 6i. That quantity minus 3 minus 7i. Okay, that minus sign is going to change. It's going to change this to a negative. It's going to change this to a positive, and then you're back to adding. So 4 plus a negative 3. 1. 6i plus 7i. 13. Wait. Did I write that right? Okay. Yep. Yep. Change it. So you'd have 6i plus 7i be. Wait a minute. I left off part of the answer. Sorry, I left off part of the answer. So 4 plus a negative 3 is 1. 6i plus 7i would be 13i. That look better? Okay, thanks. Okay, 16. Say they give you a multiplying. 3 plus 2i times a negative 5 minus 6i. Okay, and it's just like you FOIL it. So multiply 3 times a negative 5, negative 15, 3 times a negative 6i, 18i, 2i times a negative 5, negative 10i, positive 2 times a negative, positive 2i times a negative 6i would be negative 12i squared. But what is I squared? Negative 1. So we've got to simplify. And we can combine negative 18 and negative 10, 28i, and then that'd be a negative 12 times a negative 1. So that would be a plus 12. Keep going. Negative 3 minus 28i. That's as far as you go. Okay? So always simplify. I squared is negative 1. On all these problems, you can simplify and simplify it down. Okay, last type is if they have 5i over or divided by 3 plus 2i, you cannot leave a radical in the denominator. I is like a radical in the denominator. So you have to rationalize it. To rationalize it, you use the idea of difference of two squares, like a plus b times a minus b. So whatever this is, you're going to rationalize it by multiplying by the other sign. Okay, so if you multiply the denominator by that, you're going to multiply the numerator by that. Okay, and what we're doing is we're using the idea of a plus b times a minus b, square the first one minus the square of the second one. Okay, so on the bottom, square the first one. 3 squared would be 9, minus 2i, you did it 2i squared. 2 squared would be 4i squared, 4i squared. But what's I squared? Negative 1. So this on the bottom is like 9. I'm going to do it, sorry. Minus 4 times a negative 1. So that's like 9 plus 4 on the bottom is like 13 on the bottom. Okay, now look at the top. Distribute this. So that'd be like 15i minus 10i squared. But what's I squared? So that's like 15i, negative 1 times a negative 10 plus 10. So we're at 15i plus 10. And it's all over 13. When you do that, make sure you extend that division bar out. So, to rationalize an I value in the denominator, you multiply it by what they call the conjugate. So if this is a plus sign, you're going to multiply by the minus sign because you're trying to get the difference of two squares. Because you can always do I squared is -1 and simplify it that way. Okay? So, if you go back, I want to take you back just for a minute. What we did last week, we solved quadratic equations. If you remember last week, when we solved quadratic equations by graphing, we said one of the possibilities is that crosses twice. That's two real solutions. One of the possibilities where it just crossed and it had a double root. Okay, what you just did today was you solved a quadratic that does not cross the x-axis. Okay, you solved for the I values. Okay, and the I values are the imaginary units where it does not cross. Okay? Okay, that's a lot in one day, but I figured you needed to see examples of all of it. Okay? So, the other thing is, like, for what you did, let me take you just from the top. What you did today was complex numbers. That's huge in Algebra 2. Okay, then you took the complex numbers, and we have the real numbers. And then we have the pure imaginaries. Okay, put the pure imaginaries and the real numbers together, you get the complex numbers. The real numbers split up into two things. Do you know what they are?
No.
Real numbers are the rationals and the irrationals. Okay, and then we end up going from the fractions and the integers. The integers are like negative, like 0, 1, 2, 3, -1, -2, -3. Then the integers, split the integers up into the whole numbers. That's the 0. And the negative integers. And then you can split the whole numbers up into 0 and the counting numbers or the natural numbers. The natural numbers or counting numbers are where every little kid starts. I always tell people, don't mess around. Start counting with your kids early. Okay, you always start counting. You want them to say the number 1. That's the natural numbers or counting numbers. Then you throw 0 in, and then you work your way up. Up to today, this was as high as you had gone up to today through your math career. Today you just took it a step higher and went up to complex numbers. Okay? Okay. I'll give you time to work. Hang on.